Oga Sydney. Oga Sydney, good afternoon. Can you hear me? Oga Sydney, can you hear me?
No, not yet.
Oga Sydney. Oga Sydney, good afternoon.
I can hear you, sir.
Okay. I just want, thank you. I just want to know whether you can hear me loud and clear.
Yes, very clear, sir.
Okay, thank you. Let's wait for others.
Okay, sir.
Okay.
We should wait for others. What did you want to do our own anniversary next year, 25 years? I think for the committee now they plan No, I don't understand. I better leave out.
We'll start by 5 on the dot. So when we start by 5 on the dot, all students are to mute their camera, mute their microphone.
Okay, noted, sir. Please give me good. Bring my biro, and I need biro. See, put that by your left. Stop there to put my clothes. Bring the jotter for me. Bring a biro and that book. I will jot some things down. I'll fall the class. I need to give me this. Oh my. Starting by 5. Never mind. That I think good they may find their mouths. It's ringing. It's ringing.
Recording in progress.
Go to this doctor said, don't come online.
This is
Good evening, ladies and gentlemen. Welcome to our revision. Today we'll be talking about our course, Fire Safety Management, for the B.sc class. However, for those who are unable to join us at the beginning of the semester, I will just try to reiterate the course content from the beginning. In this course, we are to understand fire history, definition of fire, chemistry of fire, the basic fire chemistry, the fire triangle, the fire tetrahedron, fire behavior, the difference between fire intensity and fire severity, fire development stages, classification of fire, fire extinguishers, parts and components of a fire extinguisher, fire protection in buildings, life hazard in buildings and means of escape and egress and exit, design consideration for means of escape, fire control, fire devices, control panel, fire detection, fire sprinklers, and also fire risk assessment. This is what we'll try to take in the next 3 to 4 hours. So I will advise each and every student to mute their voice so that we can enjoy the lecture together. There are 14,561 fire reported in the city of Minnesota in year 2020. According to the data, 39 civilian deaths were recorded, while 137 reported civilian cases. The Federal Fire Service in Nigeria recorded that there is a decrease because in 2021, 70 lives were lost against 147 deaths recorded in 2020. This was disclosed also that a property worth over 19.4 trillion were lost in year 2021. If you come and look at the record available in Lagos State, in 2012, the total number of fire incidents in Lagos is 126, while in 2013, the total record is 117. In 2014, the total record is 197. A clear evidence here shows us that fire is something that is very dangerous, and it's something that we have to make it very, very important in our homes, in our offices, and in our workplace. Let's go back and look at this data. It said the total amount of money lost due to fire is 19.4 trillion naira in 2021. Just 2021 alone, Nigerians we lost 19.4 trillion naira just to fire incident. I'll just give you a pictorial evidence of some of the fire incident that has occurred in Lagos. This is Balogun Market. This is Idumota Market. This is Obalende. This is also Balogun Market. This is Ijebu-Egba Market area. So this shows how important fire is to us and to the society. Each and every one of us are always happy when we want to get back to our house because we felt our homes are the places where we are safe. But contrary to fire, they said 76% of all structural fires occur in residential properties, which means most fire incidents occur in our houses. And out of the 76% of fire incidents that occur in houses, 97% of the structural fire deaths occur in residential property. So which means most of the fire incidents that occur in residential houses, and they also contribute to 97% of deaths compared to the one that happened in commercial premises or industrial premises. So fire that occur in homes are the most dangerous, and they are the ones that are even causing deaths. What are the leading causes of fire? Statistically, 5 major top causes of fire include cooking, open flame, eating, incendiary or arson, and smoking. If we look at it, most of the fire that occur in home starts from our kitchen. Most of the fire that comes from home starts from our kitchen, which contribute to 49% of all the fire incidents. Open flame, most of us, we use candle, we use boiling ring, we use things that keeps flame open. The third one is eating. Eating contributes 9%. Incendiary or arson, this is the deliberate act or malicious act of setting fire on a property or on a material or things. That is what we call incendiary or arson. This is common in Nigeria. We all know. Before we hear now, we see that CBN building, one BCBN building is burning, one NNPC building is burning, one federal headquarters is burning. Major big properties are the one that fire often gets affected. And that's why people are always of the opinion that this fire that occur in most of these commercial big places are not just ordinary fire. They are fire people deliberately set into, whether to cause a crime or to hide a crime. If corruptions or if a fraud has occurred, people always want to hide it by putting fire into such property. So after knowing that the general causes of fire in our houses are cooking, open flame, eating, incendiary and arson, and smoking, then we need to understand what is around fire itself. What is the basic science around fire? What are the things that is needed for fire to occur or for fire to start? Initially, in the olden days, we normally talk about the fire triangle, but now, scientifically, it has been proven that what we have now is fire tetrahedron. And what does fire tetrahedron means? Fire tetrahedron means, let me go back. A tetrahedron means things that has 4 sides. In the olden days, we talk about fire triangle, and that has to do with the 3 poles or 3 elements that combines to form fire. However, studies have shown that the 4th element is very, very important. So what is the first element in the fire tetrahedron? The first element is the fuel. The first element is the fuel. The second element is oxygen. The third element is heat. And the last one is the chemical reaction. The fuel, the oxygen, and the heat. That is what you call a fire tetrahedron. Now, all these elements cannot function alone without a chemical reaction combining them together. That is why the 4th element, chemical reaction, comes into place. I'll give you an example. If a car is speeding and the fuel is leaking on the road, maybe the tank has a rupture and is leaking, the driver can drive it from here till he gets to the location before he detects that the fuel is leaking. However, if the driver mistakenly match brake or had an head-on collision with another vehicle, what happened? A chemical reaction will have occurred, a spark will occur, and the fuel that has been leaking all the while will start a fire. That's where the chemical reaction comes into place. So the most important thing for us to know is that the fire tetrahedron combines the elements that forms or helps to start fire, which are the fuel, the oxygen, and the heat. Now we want to take them one after the other. Oxygen. Oxygen is abundant in nature. oxygen is abundant in nature, scientifically, we have been told that the atmosphere has 21% of oxygen. Atmosphere has 21% of oxygen. So that means normal air contains 21% of oxygen. However, for fire to start, we need only 16%. For fire to start, we need only 16%. So in nature, oxygen is present in nature at 21%. However, for fire to start, we just need only what? 16%. That is the first element of the fire tetrahedron. The second one is the heat. The second one is the heat. By nature, everything around humans generates heat. Everything around humans generates heat. If you sit down in a position for 3-5 minutes, when you stand up and you put your hand on where you sat, you feel it warm. That is heat source. If you rub your hands together, rub your palm together, after some time, you feel heat. So anything around human being, most of the thing around us generates heat. Compression of gases, electrical energy, friction, spark. Most of the thing around us generates heat. Presently now, we know that the atmospheric temperature is increasing. So the first element, oxygen, is there. The second element, heat. Everything around us gives heat. The third one is the fuel. The third one is the fuel. Fuel is abundant in nature. Fuel is abundant in nature. And the fuel that is abundant in nature can either be solid, can be liquid, or can be gases. So fuel can be in the three stages of matter, which can either be solid, liquid, or gases. So for solid, can be chair, can be table, can be wood, can be paper, can be plastic, can be clothes, or others. So that is for solid. For liquid, it can be gasoline, it can be alcohol, it can be paint, it can be olive oil, it can be anything. Anything that is in form of liquid is also a fuel. The third category of fuel is gases. Gases are abundant in nature. Gases are abundant in nature. They are natural gas, propane, butane, hydrogen, acetylene, carbon dioxide. So which means anything around human being is fuel. Human being is also fuel. Wood is fuel. Rock is fuel. Anything created by God is fuel. Anything can burn. So when we have fuel, we have heat source, and we have oxygen. What they just need together is to what? Is to form for a chemical reaction to occur, for a spark to occur, for friction to occur. Then the fire tetrahedron will start. So we said fuel can be liquid, can be solid, and can be gases, and we've given example. So when we have fuel, sometimes we also use this to classify the classes of fire that is also available. The classes of fire that is available according to the Fire Association are classified based on the materials that are. So the class A fires are the fire we call ordinary combustible materials. Class A fire are ordinary combustible materials, such as wood, such as paper, rubber, and plastic. These are what we call class A fire: wood, paper, rubber, and plastic. These are class A fire. They are called ordinary combustible material. Class B fire are called flammable liquid. Class B fires are called flammable liquid, such as oil and grease. Materials such as liquid, grease, and gases, they are what you call what? Class B fire. As compared to class A fire, which are what? Ordinary combustible materials, things that can burn easily. Class B fire are what? Liquid, grease, and what? Gases. These are class B fire. Class C fire are what you call energized electrical equipment. Class C fire are energized electrical equipment. So we have most of these things available enough around us. The motor, the motor of our electric car, the motor of the generator, or most of the things that are electrical in nature, they are classified as class C fire. In the course of the lecture, we will understand why these classes are available, because the type of fire extinguisher we use for a type of fire determines on the classes of fire. Not all fire extinguisher can be used for all fire. Fire extinguisher that can be used for all fire depends on the type or the class of fire that is available. The other one is class D fire. Class D fire are flammable metals. They are flammable metals, metals that can what? That can burn. Flammable metals, metals that can burn. And nearly all metals are liable to what? To melting and burning. Example of class D fire is materials are magnesium, titanium, potassium, lithium, calcium, zinc. We will see another class of fire, class K or class F, which is the cooking oil fire. We will treat it in the course of the class, but I just want us to know. We can be asked in the exam, question like this can be asked in our exam. List the classes of fire available, or list all the classes of fire you know. List all the classes of fire you know, and give three examples each. List all the classes of fire you know, and give three examples each. So for class A fire, you give example as wood, paper, rubber, plastic. For class B, liquid, gases, greases, and gases. For class C, energized electrical equipment, you can give different examples of energized electrical equipment. A generator motor, a car motor, engine, a motor run for a fan, or a motor run for an industrial iron or anything. So for class D, you can put magnesium, titanium, potassium, lithium, calcium. So that's are the classes of fire. So as we go on with the class now, one of the things that is associated with fire is smoke. One of the things that is associated with fire is what? Is smoke. So what is smoke? What is smoke? Smoke is a collection of airborne solid and liquid particulates and gases that's emanated when a material undergoes combustion or pyrolysis, together with the quality of air that is entrained. Which means there's an idea that says there is no smoke without fire, or there is no fire without smoke. So before smoke can come up, a fire has to start. So smoke is a collection of airborne solid and liquid particulates and gases emanated when the materials undergo combustion or pyrolysis, together when the quantity of air is emanated. So I can ask you, define smoke. I can ask you to define smoke. And what are the constituent, or what are the components of a smoke? What are the components of smoke? So these are things I can ask you to define. So as we move on now, when we sometimes classify materials as combustible and flammable. We sometimes classify things as what? Combustible and flammable materials. how do we classify things as combustible and flammable materials? So combustible materials has a flash point of 100 degrees Fahrenheit or above. Combustible materials has a flash point of 100 degrees Fahrenheit or above, while flammable materials have a flash point below 100 degrees Fahrenheit. Flammable materials has a flash point below 100 degrees Fahrenheit. That means flammable materials can ignite easily, unlike combustible materials. That is just the difference. It is the flash point that differentiates what a flammable material is, what combustible material is. In the course of the lecture, we will see, we will understand what a combustible material is, what a flammable material is, and also give example of it. So the other time I said, when fire occurs, what happened? It forms smoke. So what are the constituents of smoke? The constituents of smoke include carbon particles, sulfur dioxide, vapor, carbon monoxide, hydrogen cyanide, and carbon dioxide. So when fire starts, the first thing that we'll notice is light. The second one is the heat. The third one is the flame. And the last one is what? The smoke. That is the progression for fire. When oxygen, fuel, heat, and chemical reaction occur, there will be flammable vapor, which will arise to light. The light will give heat, it will then give flame, and it will then give smoke. So the smoke, when burning occurs, there are many chemical constituents that are released during the burning process. The chemical constituents that get released during burning process are carbon particles, sulfur dioxide, water vapor, carbon monoxide, hydrogen cyanide, and carbon dioxide. So you can be asked the question, what are the chemical materials that releases when fire occurs? When fire is burning, what are the chemical constituents that get released? Carbon particles, carbon monoxide, carbon dioxide, hydrogen cyanide, sulfur dioxide, water vapor. That is why you see that smokes often kill. When people enter fire, they die because of smoke inhalation. Because the things that are available in smoke are things that can kill people. You can see it. Cyanide is there. Hydrogen cyanide is there. Carbon dioxide monoxide is there. Carbon dioxide is also there. These are things that kills people. It will shut out the oxygen. We've talked about fire triangle, and we've talked about the fire triangle. So I said we need approximately only 16% of oxygen for fire to start. And in life, God has given us abundantly 21% of oxygen. So when fire starts, how does fire progress? When fire starts, how does it progress? What are the factors that contribute to the burning of fire? First, the amount of time the fire has burned is important. The ventilation characteristics of the confined structure, the amount and the type of combustible present. A room full of paper will burn easily and fast than a room full of metal. A room full of paper will burn fast than a room full of metal. However, a room full of metal can burn longer, while a room full of paper will quickly burn out. So there are three progressive stages of burning. There are three progressive stages of burning. There are three progressive stages of burning. The first one is incipient stage. The first one is incipient stage or the burning phase. The first one is the incipient or the burning phase. The incipient or the burning phase. This is the first stage of burning. That is where the burning starts from. At that stage, the oxygen available is rich. The oxygen available is rich. The fire is just what? Starting. Oxygen is plenty. The temperature has not built up. You can see that the temperature around the fire has not really queued up. Thermal updrift is arising. The thermal will be going, the thermal depth will be going up, and most of the smoke will also be going up. Breathing may not be difficult at this stage. So these are the characteristics of the incipient or the beginning phase of fire burning. Fire extinguishing, so if you directly application of water at the base will stop the fire. At the incipient stage, this is the stage that is very, very important for us to stop the fire, because direct application of water at the base will stop the fire. Ventilation is also not a problem because air is still available. Little steam production are taking place. The second stage is the free burning phase. The second stage is the free burning phase. At the free burning phase, the fire has evolved more fuel. The fire is gaining more power now, and more fuel are being consumed. Oxygen supply is being depleted. As the fuel are being consumed, the oxygen available is going down. As the fuel is being consumed, the oxygen available is what? Is going down. Heat is accumulated at upper areas. The heat is being accumulated at upper areas. Breathing difficulty, mask is recommended. At that stage, it's very difficult to breathe. Breathing becomes more difficult, and most especially, masks are always recommended. So for safety officer, for fire officer, it is very, very important that when you get to a scene, of fire, and you find out that the fire is at the free burning stage, it is advisable to what? To put on a mask. But if it's still at the incipient stage, where you find out that the ventilation is still available, then mask may not be recommended. But when the fire is at the free burning stage, you've seen that more than 45% of the fuel is already consumed and the oxygen available is depleted, you will need mask. Fire extinguishing in reaching the place, the area is major involvement. So you need to apply a target point fire extinguishing materials. Ventilation may not be needed because it's not daily. At this stage, steam is being produced. You see small water coming around. The last stage is the smoldering phase. The last stage is the smoldering phase. Oxygen supply not equal to the demand of fire. At that stage, the fire is already going down on its own. At that stage, the fire is already going down on its own because it has consumed all the oxygen available. It has consumed all the oxygen available. So the fire is automatically going down on its own. Temperature throughout the building is very high. The fire has burned for a longer time, and all the properties, all the materials around there has accumulated the heat of the fire, and the temperature around is very, very high. Normal breathing is not possible. Yes, at that stage, breathing becomes difficult because the smoke in that environment will have consumed most of the oxygen. So breathing becomes difficult. So it is important that mask is kept on by fire officer. Fire extinguishment is indirect method. So there you don't have to apply, you have to be cautious because you don't know where the remaining part of the fire is. So you use indirect method Here, steam has formed, and there you can see water fog around the fire scene. So this is an example of a smoldering phase. So there's difference between a fire progression and stage of fire. Sometimes people always compare the two. Sometimes people always compare the two, but they are two different things. Three progressive stage of fire. How fire progress. There is incipient or beginning phase. There's free burning phase. And there's smoldering phase. This is different from stage of fire. This is different from stage of fire. Stages of fire are 4. We have the incipient, the growth, the fully developed, and the decay. Stages of fire is different from the progressive stage of fire. So at the stages of fire, we have incipient, the growth, the fully developed, and the decay stage. The only difference is the growth here. The only difference is the growth here. We have the incipient, we have the growth, we have the fully developed, and we have what? The decay stage. So before fire can move from incipient to fully developed, or before fire can move from incipient to growth to fully developed to decay, it has to travel. So that is why we now move to our next topic, mode of fire transfer. How do fire transfer from one place to the other? This aspect of the course is normally good for fire investigating officers, fire officers, or safety specialists who are involved in investigating incident of fire. Like a fire occur, and we want to know what is the source, where is the source of the fire. So here, fire are spread either by conduction, convection, or by radiation. Fire are spread by conduction, convection, and radiation. These are the 3 modes of fire transfer. Conduction, convection, and what? Radiation. So conduction, it occurs only in solid. Conduction occurs only in solid, e.g. metallic object. I gave you example. Let me give you example. Like, everybody take your mind back to the lecture room where we normally attend our lecture. At the back of the lecture, students normally put their textbook there. Students normally put their textbook there. If one day we come and we find out that the textbook at the back are burnt, however, the desk and the chair in the front, fire did not touch them, we'll be surprised why the textbook at the back got burnt and the fire in the front did not, at the middle, the chairs and the tables and the bench did not burn. And at the front, the fire also affects the front. So sometimes we see that the fire will affect the front, the fire will affect the back, and it will leave the middle. Sometimes most of these fire are transmitted by metallic objects. So if you hold a metal inside fire, after some time, what happens? The other end that is not attached to the fire will get what? Will get heated, and you do what? You drop it. That is what you call conduction. The heat has been moved from one part to what? To the other. So sometimes fire gets spread like that. A metal is heated at the front, but at that front, there are no combustible material there, or things that are easily get flammable. They are not there. But at the end, where the fire is spreading to, that is where the flammable material is. So you see that the front where the fire started will not burn, but at the other end of the metal will burn more. That is what you call conduction. Convection occurs in liquid and in gases. Sometimes also fire spread via convection, and it does see through the liquid or gases. The other one is by radiation. You don't have to touch an object. Sun doesn't have to touch an object before it can what? Fire can start. That mode of spread of fire is called what? Radiation. So conduction, heat energy is passed on from one molecule to the other. The molecule vibrates above its mean position. You can see, like the example I gave, you can see the PowerPoint presentation. That is an example of a metal. You can see that the candle is eating one part of the metal. However, most of the molecules are what? Are the other part. So that other part gets heated and it spread the fire. So this is conduction. You see, it conducts from one place to what? To the other. Convection, when a liquid or gas is heated, it's what? It expands. The last one is what? Radiation. It doesn't have to, body contact doesn't have to occur. If you put paper, like we normally do when we are young, if you put oil in a paper, white paper, and you put it inside sun, after some minutes, what happens? You see that fire will what? Fire will start at the point at which that is what we call radiation. Apart from that, there are some other chemical reactions that produces fire. Combustion, heat, light, combustion without heat and light. Those also give to what? To fire. So why is combustion very, very important for us that are safety officer or that are fire officer or that are involved in fire? There are some fire that will start within 2 minutes and they become large. There are some fire that can burn for 30 minutes, 1 hour, and they will not become extreme. It depends on what we call the combustible capability of the material that is what? That is burning. So what are the types of combustion we have? We have slow or incipient combustion. We have rapid or active combustion. We have deflagration, and we have explosion. We have slow or incipient combustion. We have rapid or active combustion. We have deflagration, and we have what? Explosion. Explosion is the most dangerous one. Explosion is what? The most dangerous one. It is very rapid. It's always accompanied with large noise, and it generates high pressure and high temperature. So for you as a fire officer or for you as a safety officer, if you know that the material in your custody are material that can explode, what do? Immediately you find out that the fire has started, you what? You safety first. You do safety first. You will say something that will explode and you want to start to use an extinguisher on it. You are risking your life. You are risking your life. So this is very, very important. We must be able to know what are the combustible capacity of the materials I'm involved in it, so that I will know the kind of procedure I will use. It is very, very important for us to always give information to fire officer or safety officer the kind of fire material that is burning, so that they can easily know how to classify the fire. So if they want to classify it as slow or incipient, rapid or active, or deflagration or explosion, these are things that are very, very important. So when fire burn, when combustion occur, what is the rate? How do combustion contribute to the spread of fire? So fire will start, but how will the fire spread? How long will the fire be? Depends on some property. One, the area of the solid or liquid in contact with the air. So if fire is burning, and most of the material that are burning don't have contact with air, they are sealed off. There's probability that the fire will die off naturally because oxygen will not be what? Supplied. Also, the amount of heat generated to rise the temperature of onboard portion. So if something is burning, but the amount of thing that started burning did not generate a lot of heat, the other materials available will not what? Will not burn. The other materials available will not what? Will not burn. So that is very, very important. The other one is the ability of the material to conduct heat. If that material can conduct heat, burning will continue and the spread of fire will also what? Continue. Atmospheric humidity is also a factor for the spread of fire. In our country now, like this, Nigeria, we're in the tropic region, and most of the fire incidents occur in what? Dry season, because the humidity in the dry season is very low. Most of the atmospheric material are dry. The atmosphere is not moisty, it's dry. So atmospheric humidity also contributes to what? The spread of fire. Wind velocity. If fire is burning and the wind velocity is towards that place where the fire is burning is high, this will also help in the spread of what? Of the fire. Temperature also contributes to heat. Atmospheric pressure also contributes to heat. Let's leave this. Let's leave this chemical reaction. Don't let us waste our energy on that. So when fire starts and the fire has occurred, how do you extinguish the fire? How do you extinguish the fire? All the fire extinguishers that we have around us are based on principle. All the fire extinguishers around us are based on what? Principle. They are based on principle. So fire extinguishment theory. The next topic is fire extinguishment theory. How do you extinguish fire? There are 4 basic principles by which fire are being extinguished. The first one is the cooling. The second one is the smothering. The third one is the fuel remover. And the fourth one is what? Inhibition. Cooling, smothering, fuel remover, inhibition. These are the 4 theories of fire extinguishment, or how do you extinguish fire? The properties or the theory by which fire are being what? Extinguished or eliminated. The first one is cooling. What does cooling mean? Cooling means you reduce the temperature, because anything that is burning will always be accomplished by heat. Will always be accomplished by heat. So when heat, and the heat is what will give the fire more power. So what do? You try to reduce the temperature. And the adage, there's an adage in Yoruba that says, "Omini poro no," which means water is what you use to kill the intensity of fire. So the most important temperature reducing property we have in the world is water. So cooling, that's why water is mostly the first choice of fire extinguishing by everybody. Because what water will do is to cool the temperature and allow the fire not to spread more or allow the properties not to burn more. The second one is smothering. You smooth out, or you lock out, or you seal off. So what that means, you reduce the amount of oxygen that is available for that fire to use. You see, when something is burning, they will ask you to cover it with a lid, cover it with a blanket, or use something to cover it. What are you doing? You are reducing the amount of oxygen available for that fire to enter. So the second property is smothering. The third one is fuel removal. The third one is fuel removal. You have about 5 buckets in a room, and one bucket started burning. You take the bucket and you throw it away from the 5. What have you been able to do? You have removed one of the fuel that is burning, or that one is burning. You remove the other 4. It is only that one that will what? That will burn. The other 4 has been taken away, which will serve as the fuel that will give the fire more energy. The last one is inhibition, breaking the chemical reaction. So you understand the other time that we said the fire triangle, the fuel, the heat, and the oxygen, they need a chemical reaction for them to what? To combine together and burn. So these are also the part of property you can use to do what? To extinguish fire by inhibiting that chemical reaction to what? To take place. So the temperature reduction is the what? The cooling. Reduction of the heat, use sometimes that absorb heat. Use water being the best cooling agent. Water is the best cooling agent. Most use foam, which contain 90% of water. Most foam that is used for fire are always 94% of what? Water. Exclusion of oxygen. Deprivation of oxygen, you deprive it of oxygen. Secure the door. You know, I told you that when a property is burning, one of the major mistakes people normally do is they start throwing stone into the window. When you throw stone into the window, you throw something, you are allowing more oxygen to come inside and you are giving the fire more power. So exclusion of oxygen is the second one. The third one is the removing of fuel. The third one is removing of fuel. I'm just using these graphics to explain what I've said. The third one is what? Inhibition of chemical or chain reaction. That is the end of the first lecture. I'll just give us a break of 10 minutes. Just give us a break of 10 minutes. We'll come back to resume with the second class. Just give us a break of 10 minutes. No, 10 minutes is too much. I'll give you a break of 5 minutes, please. Break of 5 minutes.
Obviously, we can't guarantee a fire, is it? We can give you a pretty good idea of what it's going to look like.
The fire you've just seen was very real, even if the office wasn't. It involved materials which are typical of many offices. No special effects were used, and you saw everything in real time. But of course our fire was no accident. It was set up and ignited purposely, then filmed by experts for your benefit. What benefit? Well, normally at this point, we might be obliged to give a rather needless warning such as, "Don't try this in your office," and it sometimes gets a laugh. But by changing just one word, it becomes a serious message. By looking at why fires like this happen, it's possible to give advice on how you can prevent them. Our office fire had to start somehow. It was arranged so that an igniter, mimicking the heat from an overloaded electrical socket, caused a plastic bin and paper to catch fire.
I promise that I will.
But other sources can't be ruled out. Damaged wiring, faulty appliances,
1 million
a discarded burning cigarette, or even arson. So, our first piece of advice is easy, and it's about prevention. Don't use appliances with faults or damaged wiring. Don't overload sockets. Don't leave anything switched on unless you need it, and be careful with cigarettes, matches, and waste paper. A quick walk-around inspection at the end of each day would mean that most of these hazards could be spotted. You should also look for windows and doors left open.
Mute your phone.
Every fire needs oxygen to keep going. Starved of oxygen, as it would be with all windows and doors shut, a fire like this becomes much less severe, more contained, and it's even possible that it will go out on its own. So, here's our next advice. Make sure windows and doors are shut when everyone's gone home. The people using our office haven't been too careful, as you can see. And after only 60 seconds from the first flame, a fire has taken hold. Although if anyone happened to pass the office, they probably wouldn't notice the fire. But there is rapid growth, and after only another 60 seconds, flames are reaching the ceiling. A passerby would easily see the fire, but is unlikely to be able to put it out. It's around this time that a fire or smoke detector would trigger. And this brings us to our next piece of advice. Make sure your office has detectors installed that not only have an alarm, but which are part of an automated system which calls the fire brigade. You can see by the speed and intensity of the fire how important early firefighting is, especially when you realize what's happening above our office. Flames have penetrated the ceiling tiles into the void above, where there may be other materials which could transmit the fire. The risk to other parts of the building, perhaps housing other businesses, is obvious. The potential for damage and loss, huge. It's still only 3 to 4 minutes since our fire started, and the severity of heat being generated can be seen by the smouldering and then spontaneous combustion of objects in the room. Watch the desktop. Flashover follows quickly. As flashover consumes everything in the room, it's appropriate to give our final piece of advice. And it's simply to remind you of good computer practice. Make regular backups of all your important data and store them somewhere else. If you are in any doubt, just consider this. Home Office records show that about 1/3 of businesses which experience a major disaster, including a fire, fail within a year. Which is where we came in. We asked you how you would feel if you knew a fire like the one you've just seen was going to mean the end of your job. Obviously, you'd feel pretty bad. But it doesn't have to happen. By taking on board the advice we've given you, you could be saving...
Welcome back. I think our break is over. We've been able to enjoy that little video. And from the video, you can understand some of the terms and languages we have used at the first part of our class. So let's continue with the class. Let's continue with the class. And Share. So we start when fire occurs. It can be dangerous and there could be loss of life, loss of friends and family, injury and disability. So when we know that fire can cause all this, what then should we do? We should put in a fire protection and prevention strategy. We should put in a what? A fire protection and prevention strategy. So fire protection includes procedure for preventing, detecting, and extinguishing fire. Fire protection and prevention include preventing, detecting, and extinguishing fire. You have to prevent fire from occurring first. That is the goal of a safety or fire officer, for fire not to what? Occur. So when fire, now you have not been able to prevent it. So when it occurs, how early did you detect it? Like the video we watch now, you can see that the fire does not take more than 3 minutes before it escalates. So detecting fire quickly is also one way of preventing and protecting the property. So if we can't prevent it from occurring, and if we can't detect it earlier, how do we extinguish the fire? So the procedure in these 3 areas of fire prevention aim is to prevent employee and property for what? From destroy. So facility fire prevention program, if you're a fire officer, if you're a safety officer, what is your role? What do you need to put in place? How do you detect fire easily? How do you initiate evacuation of the building? How do you confine the fire to one place? How do you extinguish the fire? So as a safety officer, this is one of the key things you want to put in place. So when planning a fire protection program, first make a statement of an objective. So each company has what you call objective for fire safety, objective for human safety, objective for environmental safety. So every company has its own objective, has its own. So also for fire, we must have our objective. When designing the plant, when designing the building, when designing the place, what are the fire measures you put in place? I'll give you an example. It is recommended for everybody now, whether you are building a bungalow, you are building a story building, no matter the form of housing you are building, make sure that your kitchen is concrete. Always concretize your kitchen. If we look at the beginning of the lecture, we said 36% of fire incidents occur as a result of cooking in homes. So if cooking is the major contributor of fire in homes, and this starts in the kitchen, what should we do? We should prevent the fire from what? Spreading from the kitchen. So we normally advise that you put a fire door or a metal door in your kitchen. And you know what? Concrete your kitchen. Concretize the roof rather than using POP or using wood. Because when the fire starts in the kitchen, if you concretize it, there's probability that the fire will remain in the kitchen rather than spreading from the kitchen to other parts of the place. Architects and engineers must realize that designing for fire protection is a legitimate part of their responsibility. In most advanced countries now, even in Nigeria now, planners, engineers, and architects are being taught fire prevention procedure in building design. in plant design. So you want to design a building. At the conceptualization of the design, you must put in place fire prevention system, fire protection system. This is very, very important. They must understand that there is a special thermal load that fire puts on structure. So if fire puts a load on the structure, so while you are designing the building from the beginning, you will have incorporated that in it. You must also know that preventive measure can be included into their design. What kind of structure, what kind of lining materials are you putting in your building? Are you designing into your building? This will help you to prevent fire. We will know more that in another part of the lecture. So for fire protection engineers, it is highly a developed skill. The solution of many of the fire protection problems requires that special training and perspective of experience are needed. So this is part that is new in this country, but it is something that we must achieve. So it involves an architect, interior designer, urban planners, building contractor, electrical and structural engineer, fire detection system manufacturer, building safety engineer, and local fire officer. We must all sit down and find a way to design buildings that are less prone to fire. The second part is after designing your building, after having everything in place, you must continuously have fire drills. You must continuously have fire drills. At the end of this lecture, we'll go to, we'll talk about risk assessment. In the United Kingdom, it is expected that any building that occupies more than 5 people must carry out a fire risk assessment. But I don't think this is in any of the fire regulations in Nigeria. So you must be able to do that. Also, you must prepare an emergency manual to outline procedure and drills to assign responsibility to each individual involved. Do you have fire wardens in your office? So if fire occurs, whose responsibility to do this? Whose responsibility to do this? If you have people that are challenged, who will help them? These are things we must also prepare for. Careful plan, periodically carry out fire drills. We must do it periodically, not wait till when the fire occurs, because people can often forget their role. Companies should put old design review meetings. You know, sometimes the plan people submit to the town planning authority are not what they design, what they build in their houses. So that is why periodic check should also occur, because if you submit your building plan to the town planning and you get approved, and that plan is sent to the fire department. So if fire occurs in your house, the fire department will be looking at the design you submitted to access your building or try to see how they will evacuate or do something. However, you have changed the design. You have changed the design, which is not what you submit. So these are part of the thing that often hinder rescue purpose. Fire prevention also includes towards preventing fire from starting at the beginning. Inspection. This is also very crucial. Set up a system for periodic fire inspection for every operation. Is it weekly? Is it monthly? Is it quarterly? Buildings that are well designed, provided with protective device and construction elements should still need periodic check. Some buildings they have sprinklers, they have hose drill, they must be periodically checked. Not the day we want to use them and we find out that they are not functioning very well. This is very, very important. In large plants, these jobs are also done by people. So the inspector, the chief fire, or other individual from the plant is also in charge of fire prevention. Some people always complain when fire officers come to their facility to come and check. This is part of the routine functions they are supposed to do. They are supposed to come to your facility, check periodically, and see. So if you are the safety officer in your company, you should guide them properly, you should cooperate with them, rather than, because their little professional advice will help you and also save your organization. So what would they check? They'll check the valves, whether they are supplying water very well. If you have an automated system, if you have an hydrant, if you have hose, if you have sprinklers, they want to check your portable fire extinguisher. When last did you service your fire extinguisher? Do you have fire door? Are they adequate? Are they properly labeled? Do you have communication system that are easily? So these are things they will check. So do you know the necessary phone number that will give you the immediate access to the fire officer? These are things that are very, very important. Also, do you have fire detection devices? Do you have fire detection devices? These are part of fire protection system that should always be checked periodically. You know, sometimes people say human beings are good observers, but now we have automated fire detection system that can even give warning more than human. So first, safe building design and site plan. This is also very important. How do you design your building? How do you design a building? You have a multi-story building, like in Lagos now, we are having buildings, 15, 18-story building, 20-story building, and you don't have enough parking space in your frontage. So if the fire trucks come, they won't be able to have a place to stay to attack the fire in your facility. They will have to stay in the front of the road. And that will cause emergency, that will cause a lot of traffic. So sometimes when we design building, we should put the consideration for fire officers into it. What type of emergency procedure do you have? Do you put in place? You must have an assembly point that's over 100 feet in the building. Do most buildings in Lagos have that? These are things we must look out for. So what are the basic fire prevention things? Be mindful of fire, don't block fire exits, no smoking policy, take care where hot process are, maintain any maintenance of machinery is very, very important. Observe good security. On hearing the alarm, leave the premises, don't try to take anything. Walk quickly, don't run. So when there is fire, walk, don't run. Don't use the stair, don't use the lift. Don't use the lift. Don't delay your exit to, I want to collect my bag. I want to do this. No, it is not done. And don't go back into the building unless a fire officer has assessed the fire and find out that there is no threat in the building before you return. Do not fight a fire if it is bigger than a waste paper bin. If you find out that the fire is bigger than a waste paper bin, don't try to attack the fire. Don't try to be an hero. Leave the job of fire to the expert. If you discover a fire, raise the alarm and evacuate as quickly as possible. Maintenance and inspection is very, very key for fire prevention. Maintenance is very key. You must check your fire extinguisher at least once in a month or quarterly. So our next lecture is the equipment that we use to attack fire. How well do we know them? So here we are going to talk about the fire extinguisher, the types, and the operating procedure. Use of fire extinguisher. When do you use fire extinguisher? What type of fire extinguisher do you use? So we said 3 components are needed for fire to start: oxygen, heat, and fuel. And with the help of a chemical reaction, the fire will start. So I said we have the classes of fire: Class A, Class B, Class C, and Class D. And I told you that there's one other class that I did not introduce the other time, That is class K or class F in some country. Class K or class F are cooking oil fire. Cooking oil fire are what you call class K or class F. It's a new introduction by the Fire Association. So it is not only in Nigeria here. People always continue to use oil. So if you fry plantain today and you did not finish the oil, you can't throw them away. So you use that oil you use to fry plantain, you use to fry meat. Sometimes some people continue they don't throw the oil away. They just add more to it and continue to use it to fry. And over the years, fire officers have found out that when we continue to use fat oil, it's changing properties. And because it's changing properties, when the fire starts, it makes the fire to be more dangerous. That is why they give cooking oil a special class called class K or class F. So we now know that we have 5 classes of fire: class A, class B, class C, class D, and class K. So for the B.sc students, this part is very, very important. This part is very, very important. I normally like setting this question most of the time. With the aid of the diagram, with the aid of an annotated diagram, draw and label a fire extinguisher. Draw and label a fire extinguisher. So I normally ask this question. So for most of the students in B.sc, I normally ask this question. With the aid of a diagram, draw the anatomy of a fire extinguisher. So you can see the diagram. The first one is the discharge lever. The second one is the pressure gauge. You have the carrying handle. We have the discharge lock and pin seal. We have the discharge hose. We have the discharge nozzle, and we have the discharge orifice, where the content of the fire extinguisher normally comes out. We have the body, and we have the data plate. The data plate is where the information about the fire extinguisher is normally placed. The content of the fire extinguisher, what is inside, that is where the data, that is what the data plays. So for people who are B.sc students, please note this question very, very well. Hello? I can hear that my slide is not changing. Sorry. Are the slide changing now?
No, not changing. See,
It's not changing.
The slide are not changing.
Yes.
yes, sir.
Sorry, let's try and retract and see what is happening.
Yeah, it's done now. Wow. Back again.
I'm coming. It's changing now, Abi?
Yes, sir. It's changing.
Okay, but I want to put them in slide form. Let's see. Is it changing now?
No.
Is it changing?
No, sir.
It's not changing.
Yes, sir.
Oh, wow.
Yeah, it's changing now.
Okay.
Yes, sir.
Okay, so and that means I don't know, maybe the setting of the distance. So let's use this form while we continue with the class. So I said for the B.sc students, it is important for you to know the anatomy of a fire extinguisher because this may be a compulsory question in the exam. The anatomy of a fire extinguisher, you should be able to draw a fire extinguisher and label it properly.
Wow.
So now let's take the fire extinguisher one after the other. The first type of fire extinguisher we are going to talk about is the pressurized water. The first type of fire extinguisher we are going to talk about is what? Pressurized water. For us in Nigeria here, most of our fire extinguishers are normally of the same color. For most of our fire extinguishers are normally of the same color. It is the content that normally differentiates them. But in some country, the types of fire extinguisher depends on the color that is available. Some country, their fire extinguisher have different color. So the first type of fire extinguisher we're discussing is pressurized water. The pressurized water are the fire extinguisher of choice for a class A fire. The pressurized water is the fire extinguisher of choice for class A fire. That means all fire that belong to class A, you must use what? Pressurized water. And the pressurized water fire extinguisher is normally of 2.5 gallons of water and up to 1 minute discharge time. It cannot be used for class B fire, neither can it be used for class C fire. A pressurized water cannot be used for class B fire and cannot be used for class C fire. And the method of extinguishing is by cooling. The second type of fire extinguisher is carbon dioxide. The second type of fire extinguisher is carbon dioxide. It is the carbon dioxide fire extinguisher. It's used for class B and class C fire. It is not advisable for class A fire. A carbon dioxide fire extinguisher is used for what? Class B and class C. And it does not have a pressure gauge. It does not have a pressure gauge. The mode of extinguishing is by smoldering. You can only use it for class B and class C fire. The third types of fire extinguisher is what? Multipurpose dry chemical. Multipurpose dry chemical. Multipurpose because it can be used for all classes of fire. Class A, class B, and class C. It can be used for class A, it can be used for class B, and it can be used for class C. So if you are somebody that have different types of material around you, we normally recommend that you use a multipurpose dry chemical. So this is a summary of how the fire extinguisher works and which of the classes of fire they work most with. So for most of us who are not familiar with the use of fire extinguisher, yes, fire extinguisher is very, very good for us to use. But the most important thing when fire occurs is race. Race. Fire extinguisher is not the first thing when fire occurs. The first thing that normally comes to our mind is how you will rescue. You raise an alarm, you contain the fire, you now try to what? Extinguish it. Don't try to run and start carrying fire extinguisher when there are people for you to rescue. You have not raised an alarm and you just want to try to contain the fire. If you can't contain the fire consumes you and it also consumes others. So in using fire extinguisher, there's an acronym that we normally use. It's called PASS. Pull the pin, aim low at the base of the fire, of the flame, squeeze the handle, and sweep side by side. We said that is for the fire extinguisher that has pin. For those one that doesn't have pin, you what? You aim low at the base. Some people, they say this fire extinguisher is not working. No, not that the fire extinguisher is not working. You can't be pointing the fire extinguisher on top of the fire. No, that is not the source of the fire. The source of the fire is from the base. So this is very, very important. That's just the summary for it. Also, of recent, there are other fire extinguishing material that has been developed. So halon is one that was developed in the US, and it's a chemical that interrupts reaction of burning, but it has been found out that it has some carcinogenic property, so it has been pulled away. Some countries have stopped the use of halon as a form of fire extinguisher. That is what is normally used in computer or most server rooms, because it doesn't destroy the equipment. You can't use water, you can't use foam, and neither can you use dry chemical on computer or server. It will destroy them. Let's take our biro and try to answer the following quiz. Let's take our biro and try to answer the following quiz for some minutes. Fire extinguisher mark A, mark with A, is used on what? Fire extinguisher mark with A is usually used on what? You can use the chat box to answer the question. You can use the chat box to answer the question. Fire extinguisher mark with A is used on what? You can use the chat box to answer the question. Fire extinguisher mark with B can be used on what? Fire extinguisher mark with B can be used on what? How else can you kill a grease fire? How else can you kill a grease fire? Fire extinguisher mark ABC can be used on what? Fire extinguisher mark ABC can be used on what? Fire extinguisher mark ABC can be used on what? Fire protection in buildings. Let's try the full slide mode and see whether it will work. Mr. Sidney, are you seeing the changes?
Yes,
Sidney,
I'm seeing it. Yeah, with you, sir.
It's changing now.
Yes, yes.
It's changing now. Okay, thank you. So,
yes, sir.
The next topic is fire protection in building. Fire protection in building. How do you protect fire in building? Like I've said in the last class, for you to stop fire, it's not when the building is already in place. In designing the building, in even planning the building, that is when you stop the fire. So, and there are laws available in Nigeria, in different parts of the world, for us to stop, to know about this. So for Nigeria now, we have two major legislation that help us to prevent fire in buildings. The first one is the building code. There is a building code and there is the fire regulations. I know for most of us in Nigeria don't know, have not seen the building code before. We don't even know what the building code is all about. If you are building this type of building, what type of material can you use? What type of electrical installation can you put? That is what is in the building code. But Nigeria here, we don't follow those things, but it is very, very important. What kind of construction material can you use for a particular building? What is the means of escape? So if fire starts in a building, in a commercial property, in school, what is the means of escape? What are fire detection allowance systems that can be put in terms of a building? What means of firefighting or suppressing fire system can you put in different classes of building?
Sorry, sir, it's not changing again.
It's not changing?
Yes, sir.
I don't know what's happening to the slide though.
Yeah, it's okay now, sir. It's changing now.
Okay. So
Yes, sir.
for building in fire, we normally classify building in fire into 3 different classes. We normally classify building in terms of fire into 3 different classes. There's class A, class B, and class C. Class A, class B, and class C. Class A types of building are buildings that are with what? Complete non-combustible construction. They are buildings that are with complete non-combustible construction. That means the element of structures, the floor, the wall, the supporting structure or bricks are what? Completely not combustible. The second class, the class B, are traditional construction. That means non-combustible. They are of non-combustible material, but with wall that are what? Combustible, or with floors that are what? Combustible. The class C are buildings with combustible material. Everything with it is what? Combustible. So let me give an example of each class. For class A, they said all the building material, all the things that they used to build the building are what? Completely non-combustible. In America now, or in most of the advanced countries, buildings are built with metal now. They are built with metals. The structure, the element of structure of the building are pure metals. Even the lining, the separation, the partitioning are done with fiber materials that are not easy prone to fire. The roof are fiber materials or glass that are not to fire, that are just small fire, unless explosion from gases or dynamite. Those are the class A building. The class B building are the traditional one we find in Nigeria. Some of the materials are combustible, some of the materials are not combustible. For us in Nigeria, you will use block. However, your roof will be what? Plank. So some of the block can be something that will not easily combustible, but the roof are something that are what? Combustible. Class C are the types of building we find in our village or the one our parents are building before. Everything is what? Combustible material. The roof is plank. The body is also plank. So those are the classes of what? Or of building that we have. So for us to prevent fire in a building, designing and maintaining a safe building in the first place is the step to ensure reasonable level of fire safety. So for the building and its occupants in the event of fire, how you design the building, how you structure the building will determine how safe the people will be in terms of what? Fire. That comes up to the types of elements of structure you use, the type of compartmentalization, and the internal lining you put in the building will help. So what are elements of structure? An element of structure is defined as being part of a building which supports the building, i.e., these are the load-bearing parts. An element of structure is the load-bearing part of a building. The concrete wall, the beams, the columns, the iron, the steel that is used to hold the building. That is the element of structure. So imagine a building where the element of structure is metal, or a building where the element of structure is wood. Which one will be exposed to fire easily? The one with wood, because all the elements of structure that holds the building are what? Things that can burn easily. Compartmentalization is the subdivision of a building into compartments. Each compartment separates from others by wall or by floor. So what do you use to separate the building? In Nigeria, most of our compartmentalization are done with block. We separate each rooms with blocks. But in other parts of the world or some other parts of the country, now it is becoming new now. people are using PVC to separate their building. People are using HDD fiber to separate their building. Some are using glass fibers to separate their building. So compartmentalization also helps in knowing how susceptible the house is to fire. What do you use to compartmentalize your building? What do you use to separate the building It's also very key. Internal lining is also something that is very crucial to fire officers or safety professionals. What do you use to do the internal lining? What do you use to do the internal lining? This is also very, very important. Now it is common. POP is very, very common now. Screening of the wall is also very, very common. Wallpapers. Some of the wallpapers are not only paper now. Some of the wallpapers are PVC. So imagine a building with internal lining with PVC, it will burn faster than a building with ordinary wallpaper. A building without a wallpaper will not burn more because it's just the block. But if you have wallpaper, it's increased the burning potential. If the wallpaper are now PVC, it even gives the fire more strength. So internal lining is very, very important. Let's look at an example of how internal lining contributes to fire. An incident happened in a discotheque, like a club in Ireland in 1981. The fire killed a total of 48 young people at night. Nearly all were from a local area. I mean, some of them are from the same family. What happened there? The partitioning they used in the balcony, the seating where people normally sit at the club, the seating were filled with highly combustible toxic polyurethane foams. Highly combustible polyurethane foam. You know those PVC, those foams that they used to, we use in the cooler. What they used to make cooler not to become cold, polyurethane materials. That is what they used to do the internal lining of the discotheque. The wall of the area of the nightclub were decorated with carpet tiles. You know the carpet tiles people normally use in the olden days, which is just PVC. That is what they use. And when the fire occurs, the smoke from the polyurethane, which is toxic, and the carpet tiles was what killed the people. So sometimes internal lining, the type of lining material you use for a building, also contributes to the fire. So another thing that is very, very important in building is means of escape. Means of escape is defined by the approved documents, that means any country, as a structural means whereby a safe route is provided for a person to escape in case there's a fire. So if there's a fire, how do I escape from this building? How many means of escape is available? Those are the things fire officers are normally concerned of in. So that's why for a building, how many occupants is there? What is the total number of means of escape that is available? So what are the factors that you consider when determining the means of escape? The evacuation time, the evacuation procedure, the occupancy. The means of escape for a house that is going to be designed for elderly people will be different from means of escape for a student hostel. For a student hostel, the student can run quickly. But for a house for elderly people, old people home, they can't run fast. So the evacuation time will be different. The evacuation procedure will be different. Where a disabled or a challenged people are, blind people, or people that are using wheelchair, the consideration also will be very, very different. So don't design a building for fire prevention or prevention, and you don't put all these things into consideration. Who are the people that are going to live in that house? Who are the people that will be coming into that place? If you have a place and fire starts, and we have a lot of people that cannot walk, or they are on wheelchair, but the staircase does not have it's not wheelchair compatible, and you cannot use lift. So how will you move the people with the wheelchair? So most offices now, apart from designing their office, they need to put challenge people into consideration. Buildings with 20, 15, 13-story building are being approved in Lagos now. So one of the critical law for fire incidents is if fire incidents occur, the lift will be shut down. So when you shut the lift down, the staircase that is made available, have we put consideration for wheelchair people? How do you escape a person that is on wheelchair that is on the 19th floor? Everybody, do you consider who will pick the person? If emergency people are going to carry that person, how many challenge people are in those premises? The travel distance. So also very, very important. You may be the CEO of the company, but if you are challenged, you can't stay on the 19th floor. You can't stay on the 19th floor. You can't stay on the 20th floor. Because if there are incidents, how do you escape yourself? So these are things you must put into consideration when we are designing building in terms of safety and fire. External escape routes, emergency lighting, means of detection and giving warning, these are part of the thing that is also considered. Evacuation time is also very important for building. Evacuation time is very, very important for building. For example, if a big shopping mall that has a lot of restaurants, and those restaurants are using gas, if it's on fire, there's probability that the gas cylinders that the restaurants are using can be exploding. How do you escape? How do you move people away? How many people can you evacuate from the shopping mall in 5 minutes, in 10 minutes? How do the occupants recognize the alarm? So sometimes when most of these shopping malls are doing promo and they are playing large music, and professional tells them, don't play large music, because if there is an emergency, people will not be able to hear the emergency alarm. So for the types of building I have discussed at the initial of this lecture, for Class A construction, the evacuation time is 3 minutes. For Class B construction, it is 2.5 minutes. For Class C construction, it is 2 minutes. So if you are living in a plank house, your evacuation time is 2 minutes. If you are living in a block house with roof that is wood, your evacuation time is 2.5 minutes. If you are living in a glass house with a steel compartment, the evacuation time is 3 minutes. So you can see that all the types of building, the evacuation time is between 2 to 3 minutes. So if there's a serious fire, you have only between 2 to 3 minutes to get out of that place, because that is the approved evacuation time. Occupancy. The occupancy also determines how you deal with fire. What is the total number of occupants? What is the distribution? If most of the people who are occupying the building are on the 19th floor, and the fire has taken from 1st floor to 6th floor, and most of the occupants are on the 19th floor, how do you escape them? Do you have an escape ladder? Do you have an escape ladder? How do you do that? These are things safety officer, fire officer of every company must put into consideration. Travel distance. One thing that is very common in Nigeria now is that most of the student hostel normally have one door. Most of the student hostel normally have one door. And part of the people who have often talk against this practice. Don't put students inside hostel and have one door. If emergency occur, if fire incident occur, the student at the last room does not have a chance to move out easily. It is only students who their dormitory are close to the door that can meet the 3 minutes evacuation time. Student, we have an hostel that has over 600, 300 students, and they put one door. They say they don't want the student to escape at night. Because you don't want students to escape at night, you cram them as if they are in prison. So these are things that is against safety and fire regulation. So for some of us who will be safety and security officer, we must also look at it. And one of the key incidents that I normally use as an example for travel distance is the fire incident that happened in Ikorodu, one of the industry in Ikorodu, where the management of the company locked the staff inside because they said most of the staff normally steal their product. So they lock the staff inside and take the key away during production, and fire incidents occur. Before they could look for this thing, most of the staff have died. So because it takes a longer time for people who are the other side of the factory, if you have only one means of escape, if the travel distance by which they will escape from the fire is very, very long. So let's look at the standard regulation in terms of means of escape. So for a residential institution like care home, the single escape must be between 9 meters to 18 meters. For hospitals, 15 meters to 30 meters. For hotel, flat, and residential, 18 meters to 35 meters. For offices, 18 meters to 32 meters. For shops, 18 meters to 45 meters. For factory and warehouse, 25 meters to 45 meters. For assembly, primarily for disabled people, 9 meters to 18 meters. So also, the size of the door is a considerating factor. Also, the number of exits available is also very, very important. This is the minimum recommended. It does not mean you can have more than it. So if you have a place where you have 1 to 60 people, the minimum number of exits you must have is 1. But immediately there are more than 61 people, the exit must be more than 1. If you go to most of the event center, in Lagos now, most especially in Nigeria, they will cram people into one hall, 200, 250, 300, and they have only one exit. The other exit is the one they will be using to serve food. They said it's only for caterer, it's only for this thing. If an incident happens, how will you, when the law says a place that has more than 60 people, the minimum exit you must have is 2. Most of the event centers sit 300, 500, which means the number of exits should be more than 2. So also the size of the door is also very, very important. If you have between 1 to 60 people, the width of the exit must be 750 meters. For 51 to 110 people, 850 millimeter. For 221, it must be what? 1050 millimeters. So for every addition, you had 5 meters to it. So the general accepted rate is 40 persons per minute. So if you want to calculate emergency evacuation time, you are the fire officer, you are the safety officer. For emergency exit, it is 40 minutes, 40 persons per minute. So you must be able to escape 40 people per minute with that size of the door. We take a break for now. We just take 5 minutes break to take water while we continue our lecture in few times. Thank you. Welcome back. So we continue our lecture with goals of a fire prevention program. Goals of a fire prevention program. So when you have a building and you have tried to put every available things in place, whether residential, commercial, or industrial facilities, what next do you need to do? You try to put fire prevention strategy in place. You now try to do housekeeping issues. You try to differentiate flammable and combustible liquid. You also try to work out electrical fire hazard and also try to work out your compartmentalization. So the main goal of every fire officer or every safety officer is to save life. The primary goal of fire safety efforts of building occupants is what? Avoid injury and avoid loss of life. The second goal is to protect the property. The third one is so that operation or activity the company is doing will not go in vain. So what are the strategies for preventing fire? What are the strategies for preventing fire? We all know that for fire to occur, 3 things must be available: fuel, heat, and oxygen. So there's an adage in Yoruba that says, or generally acceptable, people often use quotes, Bible, cleanliness is next to what? Godliness. Good housekeeping habits are an important part of a safe workplace. Good housekeeping habits are important part of what? Work safe place. So why is good housekeeping important? It reduces the amount of flammable and combustible material. So imagine you are in a residential place, you have a house, and because you are the owner of your house, you decided to store 50,000 liters of petrol at home. You decided to store 50,000 liters petrol at home when you are not a gas station. You see that you are not doing proper housekeeping. You reduce ignition hazard. Like the video we watch, the fire video we watch, what happened? You can see people often overload their sockets where ignition can occur. Ensure that safe evacuation of occupants. Follow emergency procedure. This, sometimes even if incident, you go to some houses, and you see what they put in their staircase. Some people have turned their staircase to garage. You see drum, shoe, miscellaneous material that they use. So in case there's emergency, how people use the staircase? They have turned the staircase to store. The person that designed the building did not design the building, the staircase for store. So these are things that often do what? Often reduce. So general housekeeping guideline, work areas, walkway, staircase must be kept clean from what? From loose material. Never block any emergency exit. Never block any emergency exit. Keep use and store of flammable materials and composite at a minimum. Don't store more than you want in the house. Don't store more than what you want in the house. There's fuel crisis. Yes, there's fuel crisis. Yes, there's fuel crisis, but don't store everything in your house. Clean up all spills such as grease, oil, and water immediately. Clean up all things immediately. Storage guideline. How do you store? How do you store? How do you store in your house? How do you store in your house? All storage must be at least 3 feet from electrical panels. All storage must be at least 3 feet from electrical panels. So that means don't put things close to an electrical panel. So if there is a spark, because they are 3 feet away, the spark will not catch those things. So imagine putting your electrical socket on a rug. If you put an electrical socket on a rug, if there is spark, what happens? it will fall on the rug, and fire can start there. Maintain at least 3 feet clearance from heating surface, air duct, heaters, and lighting fixtures. Storage of combustible material in mechanical room is prohibited. Don't store. Some people, it is where their generator is. That is where they store fuel. Where their generator is where they store fuel. I know we don't have another place now. This thing, that is not acceptable. Flammable and combustible liquid, I have defined that at the other time. We must keep them away. So how do I tell what is flammable? How do I tell what is flammable? I normally use this analogy. Nigerians don't read labels. We are not born to read labels. Nigerians, we don't read labels. If you buy something now, it's hard for Nigerians to read the label. So if you look at nearly every equipment, there's a classification on this from 0 to 4. This is what you normally see on most of the materials. It's called National Fire Protection Association rating. It's called National Fire Protection Association, rating. So anything that you see 0 on it, in terms of earth hazard, it has no hazard. In terms of flammability, it can burn, it will not burn. How stable it is stable. But immediately you see 1, must be preheated before ignition can occur. Anything you see 1 on it, that means if you heat it, it will burn. Anything you see 2 must be heated or high ambient temperature to burn, which means even if you don't heat it, immediately you put it outside, it can burn. When you see 3, can be ignited under almost every ambient temperature. That means immediately you put it outside, it can start fire on its own. Anything you see labeled 4 on it will vaporize and readily burn at normal temperature. For you as a safety officer, for you as a fire officer, you must know product. You must know product in your company. Even as a security officer, you must know product in your company. You must know product around you. You must know the label around things within your facility, whether they are flammable or they are not. And how do you know how potent or how flammable they are? That rating will help you. That rating will help you. 0 to 4. Anything you see 0 on it, that means it will not burn, it cannot burn. 1 must be preheated before ignition can occur. That means you have to heat it before fire can start. 2 must be heated or high ambient temperature. That means if you heat it, you put it outside, it will start burning. When you see 3 on it, what happens? It can ignite under almost any atmospheric or ambient temperature. You don't need serious thing. Immediately you see 4. That means it's what? It will vaporize and it will what? It will burn. Fire safety, electrical issue. Electrical hazard are the causes of most of the workplace fire every year. Like the video we watch. The video we watch, faulty electrical equipment or misuse of electrical procedure always cause fire. Common ignition, overloading of circuit, use of inappropriate electrical device, damage or worn out wire. You are using a freezer and you are using a 12 amps. For a freezer, for AC, it should be 15 amps above. Oga, I don't have money. Help me manage this socket. You are using an inappropriate electrical socket for it. So those are things that causes. Extension cord also cause fire seriously. We've talked about compartmentalization of building. How do you contain fire? So if you compartmentalize the building, the kind of compartmentalization you use also help you to stop the fire. What is a fire door? What is a fire door? Hardly do you go to most offices in Nigeria and you see a fire door. People always don't consider it very, very important. A fire door are designed to withstand fire, heat, and smoke for a period of 20 minutes to 3 hours. So even if your property is burning and you have a fire door, it will help you to put the fire inside. That's why, you know, when I was talking at the beginning of the lecture, I said, for the new design for kitchen now, you must put a fire door in your kitchen, and you must deck your kitchen. When you concrete your kitchen and you have a fire door, it helps you to contain the fire inside it. And most of the places that they use fire door, most especially corridor of laboratory, industries, and the fire door are sometimes self-closing, and they close when you leave, they close on their own without anybody opening them. That's an example of a fire. That's an example of a fire door we can see in our picture. So life hazard in building and means of escape. These are example of disaster that has happened to building. A building on fire poses a life hazard problem to the occupant of the building, which has potential to develop into a major life loss or catastrophe. Generally now, buildings have been classified. Group A, classification of building. All buildings on Group A are residential. Group B are educational. Group C are institutional. Group D are assembly. Group E, business. Group F, mercantile. Group G, industry. Group H, storage. Group J, hazardous. So a safe exit for an occupant in a building of fire requires a safe path. We've discussed about that. Provision of adequate number of properly designed obstructive means of exit, availability of an alternative means of exit, protection of the entire rescue path, provision of refuge area, formation of organization of practice of effective drilling system, design consideration of means of exit. How do you design the means of exit? What are the things you look out for? Sufficient number of obstacle exits, safeguarding the exits against fire and smoke, availability of alternative exit. These are things that must be put into consideration. So if you want to design an exit, what are the things you look out for? All means of exit include staircase, lift lobby, corridor shall be adequately ventilated. It must be what? Ventilated. Exit not properly ventilated can cause suffocation. So if you don't put things that will allow breathing to occur, when people are trying to escape, they can what? They can be suffocated. Every building means for human occupancy shall be provided with exit sufficient to permit safe escape of occupants in case of emergency. Capacity of exit. The unit of exit width used to measure the capacity of an exit shall be 500 millimeters. A clear width of 250 shall be counted as an additional purpose. So that means the total occupancy for a particular floor must evacuate within 2.5 minutes. That is what we use for, if you want to evacuate people from a building, the time rates as safety officer or fire officer is 2.5 minutes. 2.5 minutes is the rate. So those are things. All buildings which are 15 meters in height or above, such as education, institution, industrial storage, hazardous occupancy, must have more than 500 square meters on each floor, shall have a minimum of 2 staircases. Don't design a building that is above 15 meters high without having a floor that is meant to what? For emergency. Don't build all your building and do what? And use them as office legs. We see it in this part of the world. So if the fire starts from the ground, where would be the assembly point? Where would be the assembly point? Where would they use the fire ladder to meet people and escape people? That should be put into consideration. Width of the staircase. The width of the staircase also determines the types of building. The types of building determines the types of the staircase, the size of the staircase. Not all buildings have the same size of staircase. So for residential building, it is 1.0 meter. For residential, for me, that means hotel, 1.5 meter. Assembly buildings such as auditorium, theater, and cinema, the staircase should be 2.0 meter. Educational building up to 30 meter in height, 1.5. Institutional building like hospitals, 2.0. All other buildings, 1.5. Don't design the same staircase for residential and design the same staircase for what? Education. It is not accepted in terms of fire prevention. So like I said, there are legislative requirements. The building code in Nigeria is also there. The fire regulation is also there that can guide us. I've talked about this before, talked about internal factor for consideration. I've talked about evacuation time. We've discussed about it. So let's go ahead. So after putting all this in place, you have our building, we have designed the means of escape. How do we detect fire quickly? The best way for us to detect fire quickly is using fire devices. The best way to detect fire quickly is to use what? Fire devices. So we will now talk about fire devices. The first level of fire prevention, is what? Preventing fire. And what do? You design your building, you put in administrative control. Level 2, fire detection and extinguishing. You put an active fire protection system. The third one is, yes, we could not detect the fire, we'll mitigate it by what? Using fire extinguisher. So fire detection, early fire detection is very, very important. Early fire detection is very, very important in fire prevention. So what are the types of fire detection devices we have? We have a smoke detector, we have heat detector, we have flame detector, we have linear heat sensors, we have beam detector. There's smoke detector. There are two types of smoke detector. There's ionizing, there's optical or photoelectric smoke detector, there's heat detector, there's flame detector, there's linear heat sensor, and there's beam detector. There's smoke detector. There are two types of smoke detector. There's ionizing, there's optical or photoelectric, there's heat detector, there's flame detector, there's linear heat sensor, and there's what? Beam detector. For B.sc students, this is very, very important. How many fire detection devices do we have? How many fire detection devices do we have? We have smoke detector, ionizing. We have smoke detector, optical or photoelectric. We have heat detector. We have flame detector. We have linear heat sensors, and we have beam detector. This is the picture of different types of fire alarm system that we have. You must have seen one of these two wherever you go. They are in offices, they are in shopping mall. Some are with sound, some are without sound, some are automated, some are semi-automated. So each of these fire detectors are very, very important at different types of fire stages. At the incipient stage of fire, no significant smoke, heat or flame is visible. So at the beginning of the fire, you won't see smoke, you won't see heat, you won't see flame. So which detector is very, very important at that time? So most especially ionizing type smoke detector are used at the incipient stage. At the smoldering stage, where smoke is coming up, you normally use optical or smoke detector or beam detector type. So you must know the type of fire, you must calculate or be able to determine the types of fire you want to deal with so that you know the type of smoke detector you want to buy. So a smoke detector are typically round in disc. You can see it from the picture. Some are used in commercial property. People are now using them in residential. So type of smoke detector, it can either be ionizing, it can be photoelectric. Another thing that we normally install to help us to prevent fire is sprinkler system. Sprinkler system. A fire sprinkler system is an active fire protection measure, sometimes containing water supply, providing adequate pressure and flow rate to distribute water using a piping system, a sprinkler system. For most of us who have gone to the new and modern hotel, you see something hanging along the corridor of the hotel or most of the commercial premises. That is what we call a sprinkler system. There are three types of sprinkler system. There are three types of sprinkler system. There's standpipe system, there's wet standpipe. There are two types. There are wet standpipe and there are dry standpipe. Sorry, there are two types. There are wet standpipe and there are dry standpipe. That is an example of a sprinkler system. You must have seen them in hotels, shopping mall. You know, you can't buy fire extinguishers that, but for shopping mall and big hotel, or new offices, modern offices, they use sprinkler system. So some of the sprinkler system are either wet or dry. They are either wet or dry. Heat detectors. So we also have heat detector. So sometimes some fire will not just start smoldering or will bring flame. It is the heat that will start. So heat detector is also another fire alarm devices that has been developed to help us to do what? To detect fire easily. So the next one is hose reel system. An hose reel system is intended for the occupant to use during early stages of fire and comprises of a hose reel pump, a fire storage tank, a hose reel, a pipe work, and valves. The hose reel is like the premises preparing, acting in form of a fire officer. You have an hose reel that can extend through the premises. So some are putting it in place now, because like if you have a mall that's occupy about 30 hectares, or a premises that a facility that is very large, an industrial complex, they normally put an hose reel system there. That's an example of an hose reel. So some are automated, some are semi-automated, some are dry, some are wet. The wet one have water in it 24 hours. The dry one, they will pump water into it when they want to use it. So if you look at most of the new building, you see the hose reel. That's the fire hose. So, and there are different types of hose reel. There's attack hose reel, which is the fabric one. There's supply and relay hose reel. There is forest hose reel, which is normally used most especially in forest fire. There's booster hose reel. There's suction hose reel or hard suction, which is mostly common around here. Also, there are standpipes. Another form of fire extinguishing devices is standpipe. Standpipe is type of rigid water piping, which is built into multi-story building in a vertical position to which fire hose can be connected. That is a standpipe. I'll show you the picture of example of a standpipe. Standpipe are classified as class 1, class 1 system, class 2 system, class 3, and they have different diameter and different connection pipes. So see this is an example of a standpipe. There's wet and there is dry. There's wet and dry. The standpipe normally help fire officer. They don't have to be running up and down. The manual one, the fire truck will just attach to the standpipe and it will help the fire officer go up and they get the water from there rather than taking the water from the bottom floor. While the automated one, it has a water tanker or a water reservoir already, and a pump is available to help to dispense the water. So these are the types of standpipe. They have automated dry, automated wet, manual dry, and manual wet. The standpipe or the riser system is also, there is wet one and there is dry one. Now, a new one is being added, which is the suppression gas system. A suppression gas extinguishing system consists of gas cylinders, steel piping, discharge nozzle. Gases are now being used as a form of fire suppression devices. I told you earlier that halon was first used in helping to stop fire, but because of the carcinogenic potential, it has been stopped in some countries. However, other fire experts have developed other suppression gas systems. So there are gas systems that are being used now. So some are wet chemical system and some are foam system. Principal type of alarm system, all fire alarm systems work based on different principles. There is conventional one, there is analog, and there is addressable. Fire detection alarm system are of different types, and some are manual, some are automated. The one we are all used to is the one that will break the glass. You use an hammer to break the glass and the alarm will sound. Some are just the press of the button because of automated one. Let's give ourselves a 5 minutes break. Let's give ourselves 5 minutes break before we go to the last class, last part of the lecture. Thank you.
Go that side.
Sorry about that. I think we had a network issue. Let's continue with our class now. So the last part of our lecture is fire risk assessment. Fire risk assessment. If the slide is not moving, please let me know. So under fire risk assessment, we'll define what is risk. We'll define risk in relation to fire, the process for fire risk assessment recording and reviewing the procedure, the preparation of emergency plan, and so what is fire risk? Sorry, please let me know if the slide is moving and if the slide is not moving. Fire risk.
The slide is not moving.
The slide is not moving again. Let me remove it from. Let me remove it. I don't know what is happening. So let me remove it from the. Let me remove it from the full mode. The fire risk is a summary measure derived from a fire risk function. So what is risk? Risk is probability consequence of a given scenario. So what is a fire risk? Fire risk is looking at how risky a place is prone to fire, or what are the scenarios by which fire will occur in a particular place. In more layman terms, fire risk is the combination of fire scenario, probability of occurrence. Probability of occurrence of those scenarios by which fire will occur. That is what we call a fire risk assessment. So a fire risk assessment is a review undertaking of a building in order to assess if fire risk or other recommendation to make for the building to be safer. In the United Kingdom, if there are less than 5 occupants in a building, you don't need a fire risk assessment. But if there are more than 5 people in a building, you need to do a fire risk assessment every day, every year, and needs to be documented and communicated to the fire authority. But in Nigeria, that is not in our law. But that does not mean every organization, every safety officer, every fire officer for a company should not do a fire risk assessment and have it documented in part of the HSC document for the company. So how do you do a fire risk assessment? What is involved in a fire risk assessment? The fire risk assessment or risk science has 4 elements. Ask 4 elements. Risk assessment has 4 elements. There's risk evaluation, there's risk communication, there's risk perception, and there's risk management. Risk assessment, how do you evaluate the risk? If you evaluate the risk, how do you communicate it? If you communicate it, how do people perceive it? How do organization top hierarchy perceive your communication? After perceiving it, after understanding it, how do you manage those risks? Those are the elements of a risk assessment, fire risk assessment. So risk assessment or risk evaluation is a scientific or mathematical discipline which is sometimes subjective and it is also controversial. It is subjective and it is controversial. Sometimes it can be quantitative and it can also be qualitative. It can be quantitative and it can also be what? Qualitative. Is the materials harmful to a woman under consideration, or is the process by which the organization activity is functioning? that is actually causing the risk. These are things one needs to understand. So the steps for risk assessment, if you want to carry out a risk assessment, what do? The first thing you do is identify people at risk. What are the people at risk? A company that employs aged people, or a company that has people more than 50 or 60 years above as the highest population at the workplace, they are at risk than a company that has young age as most of their staff. So you must understand, identify the people at risk. How many challenged people at work? How many blind people? How many people using wheelchair? How many people needed aid for them to move around the company? So that is the first step you do when you do a fire risk assessment. The second one, identify the fire hazard. Where do our fire hazard come from? Do our electrical current fluctuate all the time? It's our electrical load higher than what we receive? What kind of material do we store in our premises? What kind of material do we use or work with in our industry? If my industry is classified as highly hazardous industry, if we use acid, if we use explosive, those are things that will identify as what? Hazard. Evaluate and remove or reduce the risk. You now evaluate the risk. From what point to which point? Which one is more severe? Which one is less? Which one has high potential to initiate the fire? How do we reduce it? Then you record your findings. So we record our finding. In this company, we have more than 10 people that are above 70 years. So if we are developing our emergency plan, if we are doing our training, this will be the first set of people that we need to evacuate from the facility. Our warehouse is too close to our generator house. So if our warehouse contains hazardous materials and our generator house is close to our warehouse, so if there's fire, what happens? Which means if the fire starts in the generator house and our warehouse that stores hazardous materials are close to each other, there's probability that the fire will escalate. So if we have people that are old, or we have challenged people, we need to train people to know how to take them away in terms of emergency. This is risk assessment. This is assessing the risk by which my facility or my company is prone to in case of fire. You review and update the fire risk assessment regularly based on what you have. So the first one, identify the people at risk. Have you identified who is at risk? The number of aged people, number of challenged people. Have you identified why they are at risk? Some people have phobia for fire. Some people have phobia for heights. So if somebody has phobia for height and you put the person at the 5th floor or 7th floor and the fire starts from the ground floor, there's probability for that person to jump because he has phobia. So if you have identified that Mr. A has phobia for fire and his office is at 7th floor, these are people who quickly plan for emergency evacuation because the more they stay, the more they get agitated, which puts their life at risk, which put the company image also at risk. Identify the fire hazard. Have you identified the potential fire source? What are the things that can ignite? What are flammable things? What are combustible things that are available in my organization? Have you identified potential ignition source? Where could the fire come from? Where is the electrical panel? Where is the electrical panel in the facility? Where is the transformer? How close is the transformer to other source of fire? Have you identified potential source of oxygen? You can't be putting cylinder close to a place that is used for fire. So these are the second step in fire risk assessment. You now evaluate the risk. Are your fire safety measures adequate? How many fire extinguishers do we have? How many fire extinguishers do we have? Each of the fire extinguishers we have, are they adequate for the types of fire hazard that we have planned for? Like we said, there's a particular fire extinguisher that can be used for a particular source types of fire, class A, class B, class C, class D, and class L. Do we have the fire extinguisher that can take care of all the fire we expected to come from our facility? Our staff trained properly? Do we do fire drill? When last did we do our drill? Have you taken steps to reduce the source of many fuel you have? Is action taken to ratify this problem during fire drills? Have you evaluated the risk to the person in the premises from fire? Have you taken steps to reduce source of ignition? Are the person using the premises aware of emergency fire action plan? Most people don't know that the company has an emergency fire action plan. Have they gone through it? Have they read it? These are things you want to know. How many people know where the fire extinguisher is? If the safety manager or the HSC personnel are not available, who else can handle the fire extinguisher? Who else can coordinate the fire emergency evacuation procedure? Do staff or others know what is expected of them in terms of reducing the risk of fire? These are things you do. Means of detecting a fire. Can the means of warning be clearly heard if you have an alarm? Can the person at the highest floor hear the alarm? Can the person at the ground floor hear? If somebody is at the toilet, if somebody at the storage room, can they hear about the alarm? These are things you need to do. Are there means of detecting the fire in the right place? Is there an emergency fire action plan? Will the existing means of detecting the fire be assured that, yes, everybody sees the fire extinguisher visible? If they are not visible, are there signs to tell people that where the fire extinguishers are? Don't have fire extinguisher and go and put it in the store. These are things you want to do. Are escape routes easy? Have you assessed the potential of the fire, the heat, the smoke? You know, earlier in the class, I said, you go to most houses and you find out that the staircase has been turned to garage. People store a lot of things in their staircase. And if they are emergency, that's where people should use as a means of escape. How can they escape when the whole place? So are the means of escape routes clearly identified? Are all the escape routes and final exits clearly clear? Can all final exit doors be opened easily without serious, not that we have to go to the ground floor to take the key? So these are things you need to do. Escape route lighting. Are emergency lights in place to help us to identify that this is an escape route? Are proper signs or appropriate signal showing the direction to where people should take in case the emergency? These are things you want to check. Test and maintenance. Is there a regular check of all firefighting equipment? Is there a regular check of fire detection and alarm system? Do you have regular check fire door? So these are things you want to do. Step 4, record all your findings. So you record all these things together and sit down and look at the shortfall of the organization to the proposed action plan. Have you recorded the significant findings of your assessment? Have you recorded available inspection for the enforcing authority? So when fire officer come, they issue warning. The warning is not for you to be panicking. The warning is for you to see that, okay, these are things we are doing right. These are things we are not doing right. Have you recorded what you have to do, what's to be done to remove the risk? You review and revisit. Sorry, it's revisit, you review. Do you review your fire risk assessment when there are reason to suspect that your assessment is no longer valid? Your organization started with 5 people. Now your organization has 50 people. And you still want to use the fire risk assessment you did with 5 people. No, there is need for you to review it because the population has increased. The diversity has increased. Having reviewed your fire risk assessment, our fire measure, the new fire measure you put in place, are they adequate? So this is an example of a fire risk assessment that we have, but it's not really legible. but I'll share it in the class or share it with the slide. Thank you, ladies and gentlemen. I think we have rounded up our semester. So if you have any question or any observation, we'll share the slide. Some of you have the slide already. If you go to the B.sc class platform, all the lecture materials are there. So thank you, ladies and gentlemen. You can on your camera and unmute yourself if you want to talk, and so that we can see the people available with us. Thank you.
Hello, sir.
Hello, sir.
Yeah. Sir, I want you to resend some of those material you sent on the group, because I changed my phone. Unfortunately, I lost some of the materials, sir. If you can do that for me, I would appreciate.
I'll do that. I'll do that again. Thank you.
Thank you very much, sir.
The man that normally comes for lecture from Port Harcourt, I think he got to Port Harcourt this morning. Maybe he's tired and he's unable to join us. And the other guy from Ibadan also.
My handout, sir. How am I going to get you, sir?
Your handout. Your handout. I said send your address. Send your address. I will. Yes,
okay, sir.
Send your address.
I'll do that, sir.
Chat me personally and I will send your handout to you.
Okay, no problem. Thank you very much, sir. I appreciate it, sir.
Okay.
Yes, sir.
I think we've tried today. Abi? I'll see you people second semester. Our exam is June. So we'll do our mock exam third week of May. Hey, man from Port Harcourt, you are there. Thank you. Thank you. You are trying, You are trying, You are the one we should use as Nigerian president. You are trying, moving from Lagos to Port Harcourt and coming over back. Now, good work, You are trying, You are the kind of person we should use as Nigerian president.
Thank you, sir.
Thank you, sir. So I'll put the recording. I'll put the recording on YouTube. I'll put the recording on YouTube, and people who miss the class can use it and join. Thank you, ladies and gentlemen. We'll see you next Saturday.
Okay,
enjoy
sir.
The rest of your holiday.
Yes, sir. Thank you, sir. Bye-bye, sir.
For the Muslim among us, Barika de Salah. And if you kill ram, bring our ram to school on Saturday. Thank you all. Bye-bye.
Bye. Thank you.
Thank you, sir.
Thank you. Bye-bye. I appreciate.
Thank you.
Enjoy the lecture.
Thank you, ma'am.
Yes, sir.